Welcome to my talk, Zero2Hero Red Team Tradecraft. Quick disclaimer, I finished these slides 2 minutes ago. So I got way too excited when submitting my CFP, and now there's a crap ton to cover. There will be a blog post going through everything in a lot more depth, more topics, as well as I'll be sharing a full, pre-recorded thing on Twitter afterwards. So about myself, I'm Jordan J, I'm 20 years old. I've been consulting for a year and a half, currently work with JumpSec and previously with F-Secure Consulting. I've only done sixth form, so my IQ is, I believe, 4. And I have successfully rickrolled the FBI. I am the top 1% try hack me just like everyone else on the platform. And I'm currently holding you away from the bar, so no problem. So, as you can see, there's a lot of content. The bottom two I've cut out just to save time, and I'm going to try and rush through lots of it as quick as I can. Worth mentioning, obviously it's a Zero2Hero. I've tried to take more so kind of fundamental techniques here and show you guys how those work, because they pretty much apply to any type of payload, phishing, post-exploitation, whatever you like, credential harvesting, whatever. This is mostly defense evasion. So the first thing, which is quite a heavily debated topic, is whether you should use staged or stageless payloads, right? So there are issues with both, and both are kind of useful in either situation. Everything in red teaming is situational, unfortunately. So the biggest thing, in my opinion, is stages are really dumb. They will make a lot of assumptions. For example, say use Metasploit or Cobalt Strike. It will, assuming that the parameters are correct, or there's a cookie that you're using, or something that it's looking for, it will instantly just send you the payload, and the blue team now has your payload just by mimicking your request. However, stageless payloads are massive. If you've ever used something like Sliver or anything Go related, you're looking at easily 10 megabytes or above, which if you're trying to fit that in a Word document, it's going to take you a while to paste it. It will probably crash. There's advantages to both. As you can see there, I'm not going to read through all of those. Ultimately, it's all situational, and just being aware that both are an option is kind of key. People typically forget stageless payloads exist, so just bear that in mind. So the importance of encryption. So here we have two POCs. They are both very simple self-injection. What that means is essentially we've got a piece of shellcode, which is just like assembly or executable code, but stored as bytes. And we have made a section of memory, or allocated a section of memory, that is executable, readable, and writable. Typically, you should avoid doing that, but for the sake of simplicity, I've done it. And basically Wait. I lost my train of thought, sorry. So with encryption, it's going to make you all very sad. It's a lot of maths, and everybody hates maths, but I have a simple trick, right? We can do single byte XOR. All this does is toggles bits in our payload, and for some reason, Microsoft haven't figured out how to detect this yet. They've had Metasploit's been out for about, 12 years now? And for some reason, they still can't detect it. As you see at the bottom, we just have a very default-looking interpreter with HTTPS. On the left, this is what happens if you try and compile it without simple XOR shellcode. On the right, all it did was XOR it with the letter J. And then it bypasses Defender, including cloud protection, which is interesting. So now you're all Sigma XOR enjoyers, right? You toggle bits, you do nothing else, and you bypass everything with ease. Everyone else who's a tryhard AES fanboy gets signatured, slap entropy checks, and you're crying always. And as you can see, we have our shellcode up there. Just checking the facts in my notes. And Metasploit released in 2010, so for some reason Microsoft haven't figured out how to XOR it with all 255 bytes yet. So moving on, this is an example of self-injection. Essentially what this means is, again, we're calling virtual alloc here. I'm not going to go over exactly what everything in the Windows API does. That'll be what the blog post, etc. does. But essentially we're going to allocate a section of memory within our current process, and it's going to be executable and readable and writable. We're going to decrypt our shellcode, nice and ready. That's been loaded up there in shellcode.h. And essentially that's just a default. It's the same payload as last time. It's been pre-stored with H before I put it in there for compilation and static analysis reasons. But so we decrypt it, we write it to process memory, and then we simply create a thread of execution starting at our shellcode. What this will do, also, for those who don't know what a thread is, essentially a thread is like, imagine when you open a process, it runs code, right? If you have multiple threads, it allows you to run multiple pieces of code at the same time. That's as abstract as you kind of need it to get the understanding of what's going on. Then at the end, we make a call to wait for single object. That's just a really fancy Windows API way of saying, hey, we're going to pause for a bit. Because if our program were to close here, it's going to also close our shell, and then we've just killed our own shell, and we're a bit dumb. So, again, I'm trying to fly through this here because there's a lot. So with CreateRemoteThread process injection, this is a little bit more useful for us because we don't have to keep our malicious process open. In this case, I chose to target Sublime Text. You pick pretty much any process that your user has access to. Typically, you should probably pick something that's more used for, say, or more commonly going to be making network traffic. So something like, Teams, Slack, anything like that. Maybe a service host, anything, just not Sublime Text. And again, very, very, very similar concept, except the only difference is this time we open what's called a handle to our target process. A handle is like a way of establishing a channel of communication between processes in this case. It can be between files, it can be between a multitude of things on Windows. Essentially, it allows us to, say, for example, view its process ID, its name, where it's stored, its child process, what DLLs got loaded, blah, 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 blah. And again, we call virtual alloc. This time we call virtual alloc X, which means extended, and all that means is it just takes a handle to a process. So we pass it our target victim process handle, we store our shellcode again, we write the shellcode to the process memory, and then we create a thread, this time using CreateRemoteThread instead of CreateThread, and then we can close the handle and close the process. Our shellcode is now executing within Sublime Text, and I don't think I have a POC for that one because it's very similar to or a proof screenshot, but yeah, basically the same. So moving on to another technique, because those two obviously extremely common, very simple, and yeah. So we should try something else because it's too detected. So DLL injection. Again, this is very simplistic, fundamental, but it's key you kind of understand it before we move on to the more advanced stuff. So every DLL, or at least by default, will have a method called DLL main. I nearly just knocked over my drink. And essentially what this allows us to call, this will be called as soon as the DLL is loaded. We have every DLL, when it's loaded, is given a reason for it to be loaded. I believe that's the new name for it. It used to be called something else, and I forget now. But essentially, it breaks down into four main methods. You've got process attach, process detach, thread attach, and thread detach. In this case, I've basically made a DLL that when it's loaded into a process, it's going to make a message box for us as a nice simple POC. I have a duplicated slide there. But yeah, so next thing we need to do is now we've got a DLL. Okay, it sits there on the file system, but it doesn't do anything else. So we need to inject it into a process. So this is pretty much the most bog standard way of doing this. Again, this is very well signatured, as it's basically the standard way. There are theoretically infinite ways of doing this. But the easiest is to use load library A, which is the method you usually call if you were to load a DLL into your process. The issue we have to work around here, though, is we can't actually load DLLs into remote processes. Load library just doesn't allow for that. So what we can do instead is we can write the string of the DLL, like the entire file path, into memory of our victim process. We then, as you can see, we've got our process handle as normal, and then we allocate memory for it, write it to memory, etc. We're just writing as if it were shellcode, but this time it's just a file name. And then we're going to essentially get where load library A is within our remote process, or our victim process rather. Using that, we can then create a thread that calls load library for us from within the remote process or the victim process, and we can give it the parameter of our DLL name because that is also now stored in that process, and that way you've loaded your DLL, and then you can close your process, and that's it. So as you can see, there it is in action. We run it. Sublime Text now has angry DLL.dll loaded, and we get our message box to pop up. Nice and simple. From here, you could do, again, weaponize further. The reason this is such a benign payload is because the payload, the way you'd weaponize this isn't really specific to DLL injection, so I figured it wasn't worth much value. But we can move on to some more kind of the cool, niche, wacky stuff here. So there are multiple ways, and within .NET, there is a file traversal vulnerability for some reason, and it's been known for years and never been fixed. But upon launch, .NET programs, they're memory managed, right? And this means essentially there is a garbage collector typically. We can actually specify our own custom garbage collectors, which that sounds great, but only administrators can do this. However, due to the file inclusion vulnerability, for some reason, they only check if you, for example, put like C users and then you put like an absolute file path. Administrators can do that, but if you put like .. slashes at the start of the environmental variable, it assumes it's a relative path and it must be in the trusted directory. And thus, any user can specify a DLL. What this means is by users being able to specify this DLL, or not DLL, sorry, specify this environmental variable, whenever a .NET process is launched, as you know, there are probably loads on your system, it will now load this DLL just by default. Pure functionality of .NET. So again, we have simple DLL. The only differences are we're going to override the GC version info method. What this is essentially the first method that's called when your garbage collector is loaded. So it's the easiest without breaking things. And we have to use a version infrastructure because that's what it's going to be assumed is set. Otherwise, it won't actually carry on with anything and it will break. But yeah, again, I've just used the message box A to give us a nice, easy proof of concept this is working. And this is how you would actually make this happen. So you hop into CMD, you set your environmental variable with a bunch of dot slashes at the start, and then you put your DLL. You run any .NET process. In this case, I tried just .NET itself. And there you go. It runs your DLL. This was discovered by someone called Amonsec. I cannot find the original blog post. I think it got taken down, or maybe their company changed names. Who knows? So the next thing, and a lot more complex, is process hollowing with shellcode. What process hollowing is on an abstract level is essentially we're going to start a process in what's called a suspended state. This is where a process starts and it has one thread of execution and it hasn't executed anything yet. It's just sat there at the start of the executable ready to fire. And we tell it, no, wait a minute. And essentially, during that time, now it's suspended, we're going to locate the entry point or where this thread is going to start its execution. We locate that and essentially just overwrite whatever is going to execute with our own shellcode. We resume the process, and now whatever process we had is now executing our shellcode rather than its actual normal functions. So in this case, the first step here is obviously we're going to need to create the process. So in this case, I chose SVC host. SVC host is very commonly used for process hollowing. I'd probably avoid it if you're going to be doing it yourself. The OX4 here, that is the, I forget what the flag is exactly called off the top of my head. But yeah, no, not the create suspend, sorry, there's a parameter name. I understand that, but yeah, OX4 is create suspend, yes. But yeah, so anyway, so now we have a process that's created and suspended, waiting for us to do things. The next thing we're going to need to do is actually locate this address of where it's going to start executing code. So the first thing we're going to need to do is create a process basic infrastructure, or object, one of the two. And we're going to call ZW query information process. Essentially what this is going to allow us to do is get the base address of the PEB, the PEB being the process environment block, I believe. And an offset of 16 from here is essentially where our entry point to this thread would be, or at least the offset from the image base. So we need to find this and then the image base. So then, sorry, I'm not explaining this very well. There we go. So the next step, now that we have that and we have the address of the PEB, this is kind of what I'm trying to explain here. I gave a diagram because I knew I wouldn't explain this bit very well. But essentially, we're going to read the first 512 bytes of the PE, right? And this will give us the DOS headers, and potentially we may read a little bit into the NT headers. 512 is just kind of an arbitrary value I gave because we just need to read a lot of bytes. And as we can see, we're going to simply read the process memory from there. What that's going to do is give us all the data that is stored there and there, the PE start, and we need to essentially locate E_LFA new. E_LFA new, essentially, if we can find that, we grab that value that's stored there and we add OX28 to it. This, along with the PE image base address, will give us the start of that entry point of that thread. That sounded like a lot of spaghetti, but there will be a better blog post to follow. But essentially, all we have now, we have that entry point address. It's very, very, very simple. It's just the same as normal process injection. We'll decrypt our shellcode, write it to that address that we've just found, and we'll resume the execution of the thread. Once that's done, we have then bypassed Defender, we've got our shellback, and that's with cloud server protection on, etc. Even though it's a super documented method, and yeah, it's pretty useful, and for some reason works way too well, in my opinion. Yeah, so you can improve upon this. You can combine it with other methods, etc. One would be, for example, abusing some Microsoft executables. So if you've ever done red teaming or pen testing, or even used a corporate network, you may know of the concept of application whitelisting. Essentially what this is typically it's a system, for example, inbuilt on Windows, you have AppLocker, where that stops people from running random dodgy, virus.exes. It will only run, for example, trusted Microsoft executables. What we can do, there is a picture of what will happen if you try and run something that is non-trusted, and that also makes everyone very sad. So what we can do to get around this is we can abuse many, many things. For example, run DLL32, which you'll see a lot by Cobalt Strike as default, and also install util seems to be the kind of go-to for those who like .NET. I wrote ooh there to hurt you all. But yeah, so essentially all we need to do is override the uninstall method within install util. Reason being, again, it's kind of like the whole thing with the .NET garbage collector. Every user on this machine can uninstall things with install util, but only admins can install. So by overriding the uninstall method, we're able to kind of give ourselves two ways of executing our process. So when malware runs it, this avoids dynamic analysis, as it will typically run it and jump to the entry point. And this is fine, it will write uwu and then exit. However, in our case, we're going to run it with install util, and we'll call the uninstall method. In this case, we could have anything here. Typically, I put something to do with process hollowing, and that's kind of a nice combo. It works quite nicely. Bypasses, I think, so-forth intercept X as well. And yeah, so here we're just going to... I think actually I changed this to a message box for the POC. Yeah, so as we can see, so first of all, you run it as normal. This is how a intrusion detection system would run said thing if it was to try and figure out if it's malicious. As you can see, it just prints uwu. It'll go, okay, well, that's benign. What's the point? And in our case, we're going to be running it with install util. This is stored at the same path all the time. If you want the 32-bit version, just remove the 64 off of the framework, and it's pretty much the same path. And then the /u flag, this means uninstall, and we will call this, and then there we go. We can see, instead of giving us our uwu output, it's given us a message box. I'm aware in the POC sample here, it's console write line, but I changed it to a message box. I went through that very, very fast. But, yeah. Thank you. Any questions? I know that was kind of a bit very fast, but yeah. Yes, sir?
Who was the researcher in the custom garbage collector?
Amonsec. AMONSEC.
Is that the EX?
I'm unsure. I feel like he used to work at maybe Context before it renamed. But yeah, that was all I could find. I tried to find the old blog post, and everywhere it's linked is old and dead. So. But yeah. And this one?
Do you have any upcoming research in Breaking?
Yes. So at the moment, I've been messing around a lot with making custom packers, because I feel like a packer is kind of one of the more useful tools for a red team, because rather than trying to, for example, obfuscate something like Mimikatz or, your Cobalt Strike payloads, etc., you can just smack it all into one custom PE packer and it'll do everything for you. So I've been looking a lot into different, for example, sandbox evasion methods, such as using your CPU temperature to check if you're in a sandbox, or stuff like measuring mouse movement, etc., because people will typically just do these in an automated terminal or script, so those just won't either read or won't exist. Typically people use stuff like whether you're connected to a domain to check this kind of stuff, but it's very signatured and very easy to detect on a blue team side, whereas checking your CPU temperature is a little bit more niche. Yeah, it's kind of the stuff I'm working at the moment, but yeah.
If I want to get to Breaking, can I DM this?
Yeah, if you want. No, sir.
What does Windows detect?
I don't know how to answer that. If you were to generate a payload with MSF Venom, default payloads it will detect. If you put any effort in, more than 5 minutes, you're probably fine. Yeah, I don't know. Just literally do anything other than default, and you're fine.
You mentioned as well that it got past softbox as well.
The process hollowing with the install util combination gets past so-forth intercept XEDR, yes. For that to work, though, you do have to use a custom HTTPS certificate, because the default one in Metasploit is signatured. So deep back inspection on the traffic will show that. But other than that, it will bypass pretty easily.